All right, today we're diving into an organism that's just a master of survival. I mean, it's so good at it, it gave up having a mouth, even a stomach. We're going to go deep into the hidden world of livestock to uncover the secret life of the ruminant tapeworm. So let me ask you this. What has no mouth, no gut, and can grow up to 6 meters long, all while living inside a sheep? That's almost 20 feet. The answer, of course, is the tapeworm. It's an absolute marvel of parasitic evolution. Okay, so here's our game plan. First, we're going to look at its totally wild anatomy. Then, we'll follow its bizarre life cycle, from the pasture right into the parasite. We'll meet the main players, figure out the damage they're actually doing, and then finally, talk about how we can fight back. Right, let's get into it. First up, anatomy. You gotta understand, the tapeworm has basically stripped itself down to the bare essentials. It's gotten rid of everything it doesn't absolutely need, all to become the ultimate survival machine. It's really a masterclass in minimalist design. So take a look at this. This is the scolex. Now, don't think of it as a head with a brain or eyes. Nope. This thing is pure function. It's basically a biological grappling hook. Its one and only job is to latch onto the host's intestine with these super powerful suckers and just hold on. That anchor right there is the key to its entire existence. And trailing behind that grappling hook, you've got the strobila. That's the long, ribbon-like body. And the best way to think about it is like a freight train. The scolex is the engine at the front, and the body is just this ever-growing chain of train cars, or segments, that are constantly being made right behind it. And this is where the genius of the tapeworm really shines. Each one of those segments, they're called proglottids, is pretty much its own little reproductive factory. It's incredible. As new ones get made up by the head, the older ones get pushed further and further back. And as they move back, they mature, until they're basically just a bag stuffed with thousands of eggs, ready to snap off and start this whole crazy cycle all over again. Okay, so not all tapeworms are created equal. They basically fall into two main groups. You've got the cotyloda, which use these kind of weak grooves to hang on, and they release their eggs through a little pore, like a steady drip. But the ones we're talking about, the ones in ruminants, are called eucystoda, or true cystodes, and their strategy is totally different. They use those powerful suckers we just saw to get a death grip, and instead of just releasing eggs, they break off the entire segment. It's a total all-or-nothing approach to making babies. So you're probably wondering, how does this crazy efficient reproductive machine actually get from one animal to the next? Well, that brings us to the next part of our story, the tapeworm's bizarre and kind of brilliant life cycle. The whole thing, this entire complicated drama, depends on one tiny, unsuspecting character, the orbited mite. You know, those little guys you'd never even notice in the grass? So here's how it goes down. Step 1. The egg-filled segments get passed out in the poop onto the pasture. Step 2. A little mite comes along and eats those eggs. That mite is now the intermediate host. Inside, the egg hatches and turns into a larva. And the cycle is complete when a sheep or a cow is just grazing along and accidentally eats that infected mite. Once inside, the larva is freed, latches on with its scolex, and boom, it starts growing into a full-blown adult tapeworm. All right, so we know how it happens. Now let's meet the who. We're going to look at the usual suspects, the specific types of tapeworms that vets and farmers are really worried about. Let's get to know these guys. Okay, first up is the big one, kind of the celebrity of the tapeworm world, Monesia expansa. This is the monster we were talking about at the beginning. They call it the double-pored tapeworm because every single segment has 2 sets of reproductive parts. Super efficient. And yes, it can get up to an absolutely insane 6 meters. That's almost 20 feet long inside a sheep. Just think about that. Then you've got another major player, Styletia globipunctata. Now, this one isn't famous for being super long like Monesia. No, its signature is a little more sinister. What it does is cause these hard, distinct little nodules to form in the lining of the intestine. So it's doing a totally different kind of damage. So this chart kind of breaks it all down for us. You've got the giant Monesia expansa, mostly in sheep and goats. Then there's its cousin, Monesia benedeni, which you'll see more in cattle, a little bit smaller. And then in a league of its own, you've got Stylesia globipunctata, way smaller, only about 60 centimeters, but it's the one that leaves behind those nasty nodules. Each one has its own MO, its own way of doing business. Okay, so who cares, right? Why does all this matter? Well, let me tell you, having a 20-foot-long parasite living inside you is never a good thing. It's not just a harmless freeloader. Let's really dig into the hidden and very real impact these things have on their hosts. When an animal gets a really heavy infection, especially a young one, the signs start to become pretty obvious. We're talking diarrhea, what farmers call unthriftiness, which just means the animal isn't growing right, and you can actually measure the drop in things like wool and meat production. In the worst case scenarios, a huge tangled mass of these worms can literally block the intestine. And yeah, that can kill the animal. But really, the number one threat, the main damage they cause, is just straight up theft. They're stealing food. Remember, they don't have a gut, so they just absorb all the good, pre-digested nutrients right through their skin. They're in a direct competition with the animal for every single calorie, and that leads to serious malnourishment. And it's really a two-pronged attack. It's not just about stealing nutrients. They also cause physical damage to the lining of the intestine, and on top of that, they release their own toxic waste products into the host's system. That combination is just brutal. It leads to poor muscle development, severe malnourishment, and it's always the youngest animals, the calves, kids, and lambs, that get hit the hardest. All right, so we know they're bad news. The big question is, how do you find these hidden invaders? And what can you do to stop them? That brings us to our final section, detection and defense. So you've got to look at this as a two-step process, finding the culprit and then fighting back. The diagnosis part, it's actually pretty easy. Since those egg-filled segments are coming out in the poop, you just need a stool sample. A quick look under the microscope and you can spot the eggs or even the segments themselves. But controlling them, well, that's a whole different ballgame. It's way more complicated than just giving the animal some medicine. The real key is breaking that life cycle we mapped out. And that requires a multi-pronged attack. So strategy number 1, find the infected animals and treat them. That stops them from spreading more eggs. Strategy 2, you have to manage the pastures to stop them from getting contaminated in the first place, maybe by rotating where the animals graze. And strategy 3, which is a bit trickier, is to try and control the population of those tiny mites, the middlemen in this whole operation. You really have to hit the problem from every angle. And that leaves us with a final thought to chew on. These parasites are ancient. They are absolute masters of survival. For every single thing we come up with to control them, you can bet they're under incredible pressure to evolve a way to beat it. It really makes you wonder, doesn't it? What's the next move in this silent, microscopic arms race that's playing out in fields all across the globe?